So this is the introduction to solving exponential equations. And for this video, we're going to use the principle of exponential equality. That is, we have sort of beginner exponential equations that lend themselves to this technique. It's going to be outlined right here. So what we're doing is 3 steps. We're rewriting the equation using what's called a common base. So in other words, what a common base means is, take a look at this example. Here are the bases. See how they're both 9? In this case, we don't need step 1 because it's already written in common base. But if it's not written with a common base, then we'll go ahead and do that for the next examples. Step number 2, you drop the base. Okay, so what I mean by drop the base is, I'll show you by an example. We have 9x to the 9 to the 13x equals 9 to the 8th power. Well, you just drop the base. It's like canceling out the base from both sides. And you get 13x equals 8. And then the last step is solve for x. So at this point, we know how to do this. It's just x equals 8 divided by 13. So that would be your answer. Let's do another example. So in this one, we have e, and you could think of that as a variable, or you could think about it as, the number e equals 2.7128, whatever, blah, blah, blah. So e to the omega, that omega right here, equals e to the negative 12 omega plus 11. Okay, and you can see, once again, I already have common bases, so I don't need that first step from this procedure up here. We're instead just going to cancel out those e's, and you get sigma equals negative 12 sigma plus 11. Okay, well, now we just add 12 sigma to each side. I'm sorry, omega. 12 omega to each side. Plus 12 omega to that side. And we get 13 omega on the left and 11 on the right. So we divide each side by 13, and you just get omega equals 11 over 13. Okay, so that's our answer to number 2. Number 3, this starts to get a little more complicated, but it's not really that bad. If you take a moment to look at it, what do we have here? We have on the left 2 to the negative 9x minus 11, and then it's minus another 11, equals 53. And at first you might be thinking, well, there's no common bases in here, and you're right. But we can fix that. So let's try rewriting it. I know I'm going to have a power of 2 to the something on the left. Okay, but on the right, look, we can add 11 to each side, and we get 64. Now think about what 64 is. That should jump out to you as just 2 to the certain power. And if you don't have your 2 powers memorized, that's normal, really. 2 to the 2 is 4. 2 cubed is 8. Times 2 more is 16. 32, 64. So what is this? This is 2 to the 4th, 2 to the 5th. This is 2 to the 6th power, the 64. So we just rewrite this as 2 to the power of negative 9x minus 11 equals 2 to the 6th power. So you see, with just a little bit of work, we've accomplished step 1 of this procedure. We've gotten an equal base on each side. So now we just drop the base, and we get negative 9x minus 11 equals 6. Add 11 to each side, we get negative 9x equals, what's that going to be, 17. And then divide each side by negative 9, we get x equals negative 17 over 9. Okay, and that is your answer for this one.